So this first part is just review of solving equations using the elimination method, which we have done for a few years now. You guys did it in 9th grade. You did it in, I think, even 8th grade a little bit. So with the elimination method, it is exactly how it sounds. You are trying to eliminate one of the letters so that you can solve for the other letter. So in order for that to happen, one of the letters needs to have the same number. It's just one needs to be the positive version of that number, one needs to be the negative version of that number. So if we look here for our x's, we have a 3 and we have a 2, so that's not exactly the same. For our y's, we have a 3 and then we would have a 1 for that one. That number's not written, but it would be a 1. So what I find to do is the easiest thing is to make this into a negative 3, so then that way my y's can cancel out. I have a positive 3 and I would have a negative 3. So in order to do that, I need to multiply that equation times negative 3. So my first one doesn't change from what it is. I just rewrite it. It's still 3x plus 3y equals negative 9, because I didn't do anything to that one. The second equation, however, I'm going to multiply everything times that negative 3. So I get a negative 6x minus 3y equals a positive 21. So we just distributed. So now we can add the two equations together. So 3x minus 6x gives me a negative 3x. Our y's cancel. So the negative 9 plus 21 would give us a 12. So now we have just our x, so we can solve for that. Divide by our negative 3. Divide by our negative 3. And we get x equals negative 4. So we've got one of our answers. We just now have to get a value for our y also. I would plug it into the bottom one, yes. So we're going to plug negative 4 in for my x here. So it would be 2 times negative 4 plus my y equals a negative 7. So that gives me a negative 8 plus y equals a negative 7. So adding our 8, we get y equals a 1. So our answer here would be the point negative 4, 1. Does that all sound a little familiar now? So we're going to use that same process, only we have to do it for what we call 3 by 3 equations. So you have 3 equations this time and 3 variables in the equations. But you're going to follow the same process. We're going to still be using the elimination method. So over there to the right, I have the different directions to help you go step by step. So first thing it says to do is label the equations as A, B, and C. That just makes it easier when you're referring to an equation later on. Well, which equation are you talking about? Are you talking about equation A, B, or C? It just makes that a little easier. So now what we want to do is we want to try to eliminate one of our letters, either the X, the Y, or the Z. So as I'm looking at this, I kind of think the Z here is going to be the easiest to eliminate because you got a positive Z and then you got a couple of negative Z's. Those will cancel out nicely. So I'm going to take my A equation and I'm going to take my B equation because I have a positive Z and I have a negative Z, so those will cancel out. And I'm going to add those two together. So I get 8x minus 2y, my z's cancel, equals 50. And I'm going to label that as equation D. So instead of saying, oh, it's when I combined A and B, I'm just going to tell you it's my equation D. That's what I'm looking at now. So now what we have to do is we have to combine two equations again to get rid of Z yet again. So this time I'm going to use equation A. Even though I already used it, you can reuse it. And I'm going to use C. You can reuse one, but you can't reuse both of them because then you just create the same equation that we just did in our first step. So now when I add those two together, 2 plus negative 4 is negative 2x. 1y plus 4y is 5y. Our z's cancel, and then 15 plus a negative 14 gives me a 1. And then I'm going to call that equation E. So now if you notice, D and E both have just an x and a y. So now those are the two equations I'm going to be looking at. So I'm going to line those two up. So my D is 8x minus 2y equals 50. And my E is negative 2x plus 5y equals 1. So now using those two, we have to do like what we did up above. We have to cancel out either our x or our y so that we can get one of our values. As I'm looking at this, I got an 8 and a negative 2 for my x's, and then I got a negative 2 and a positive 5 for my y's. I think it's going to be easiest to go for x's. Well, we wouldn't want to do negative 4, just times positive 4, because it's already a negative. So my first equation isn't going to change. So that's still 8x minus 2y equals 50. My second equation becomes negative 8x plus 20y equals a 4. And again, because that 2 was already negative, that's why I didn't do it times negative 4. I just did it times positive 4 because I wanted that to stay negative. So now I combine those two. My x's are gone. Negative 2 plus 20y gives me an 18. And that equals a 54. So then divide by 18, what do we get for our y value? Y equals 3. So we've got one of them already. So now we're going to take that y equals 3, and you're going to plug it into either equation D or equation E, because those are the ones that only have 2 letters. So let's see here. I'll use D. So 8x minus 2 times 3 equals 50. I plugged my 3 in for my y. So I get 8x minus 6 equals a 50. Add our 6. So I get 8x equals 56. So what does our x equal? 7. So there's our second value. So we have y is 3, x is 7. So now we're going to pick one of the original 3's, either our a, b, or c, and we're going to plug in our x and our y value to get our z value. You want to use a? All right, we'll use a. So I'm going to have 2 times 7 plus 3 plus z equals a 15. I plugged my x and my y into my a equation. Well, no, to get my z value. Yep, got to get a z too. So I got 6 plus 3 plus z equals 15. Well, that shouldn't be 6. I got distracted. That should be 14. So that gives me 17 plus my z equals 15. So what does our z equal? Negative 2. There we go. So there's our 3 answers. And then you would check this if you wanted to just by plugging those 3 values into the original 3 equations and seeing if it works out. All right. You ready to try another one? Yes, let's try another one. Okay, example number 2 on the next page. So again, first thing we're going to do is label A, B, and C. Yep. You only have 2 equations. Alright, so let's see here. Which one do we want to get rid of first? X, Y, or Z? We're eventually going to figure them all out. You want to get rid of Y's first? Alright. So we'll start with A and C. We went with those ones because our Y's are set up perfectly to cancel one of them out already, because I have one that's a positive Y, the other one's a negative Y. So now when I combine those, I get 9x minus 10z equals negative 25. There's our d. So now this is the part where some people get confused. We have to knock the y out again. So we have to use either AB or BC. BC? All right, we'll use BC. So my B, yes. So my B is negative 2x plus 4y plus 2z equals 38. My C, I'm going to put it up here. I'm going to multiply all that times 4. So I get 20x minus 4y minus 28z equals negative 76, if my brain is working correctly. Can somebody check me on that, please? Negative 19 times 4. Yes, thank you. Alright, so now let's add them together. So I get 18x, our y's cancel, negative 26z equals negative, I believe it's 38. So now we got our D and our E. So I'm going to line them up. Always makes it a little easier, I think, when you line up your X's, your Y's, and then your numbers. So I think for this next round, probably get rid of X's. Because I got a 9 and an 18. Yes, so we're going to multiply this top one, our D, times a negative 2. So that gives us negative 18x, a positive 20z, equals a positive 50. And then I'm just going to rewrite the second one, lining everything up. So then when I go to add them, my x's cancel like I wanted. I would have a negative 6z equals 12. So then divide by 6, what do we get for our z? Z equals negative 2. Negative 6. I may have accidentally said 6, but I meant negative 6. Okay, so next we have our z. So which equation do we want to plug that into? I was going to say, I think it might be a little easier in D. So 9x minus 10 times negative 2 equals negative 25. So that gives me 9x plus 20 equals a negative 25. Subtract our 20 over, and we would get a negative 45. So what does our x equal? Negative 5. Yeah. All right. One more thing we have to do. We have to get our x, or our y value now. We got x, we got z. We need y. So which of the original should we plug into, do you think? A? All right, so we got 4x plus y minus 3z equals negative 6. So 4x, so 4 times negative 5, plus y minus 3z, so minus 3 times negative 2 equals negative 6. That gives me negative 20 plus y plus 6 equals negative 6. So So that gives me y minus 14. So I add my 14 over. And we get y equals 8. Or at least I got y equals 8. You got it too? Alright, see, it works no matter which equation you get or you use. So there's our 3. X is negative 5, z is negative 2, and y is 8. So we don't really have time for classwork, so I want you to start the third one. See if you can get it going. And then we'll go over that.